I want to show you how you can debug your training code before you actually run the training job on SageMaker. So what you want to do is you want to make sure that there are no errors, no bugs, and no issues with referencing certain directories in the Docker container that SageMaker is going to use before you deploy it to SageMaker training. So if you have cloned the repo, you'll see this structure. So the directory SageMaker container is where all the scripts that we're going to use for training resides in. So our Docker image will copy these scripts, and when we run the Docker container, the main.py is going to be the entry script that is started, and then it will run the training from there on. So what we want to do is we want to debug the code that is going to be in the SageMaker Docker container. So we're going to use this very awesome Python debugger called PUDB, which is not present in a standard library. So we're going to install it in the Docker containers environment, and we're going to debug the code in there. So first, what we have to do is we have to add PUDB in the requirements so that it will be installed when the Docker container is run. So here, I've already added PUDB here, so make sure you have added it. And now you want to make sure that you have set a breakpoint. So let's say I want to put a breakpoint here, for example. It can be here as well, if you wish, So when this script is run in the Docker container, the execution will stop at this line, and we can debug with this great tool, PUDB, in the Docker container. So okay, let's save this. So since we've made this small change in this code, we have to rebuild our Docker image because there's a change. So building the Docker image is pretty simple because I have provided this built-in push shell script, which you can just use like this, and then it will pull the base image. It will also authenticate to ECR based on your AWS credentials, and it will build a Docker image, tag it, and then push to ECR, essentially everything. So we're going to build a new Docker image with this. It's going to take a while. So while we're waiting for this, I want to show you the SageMaker config that I'm going to use. So in this SageMaker config, I've set the instance type as local GPU. So that tells that we're not going to use any of the AWS instances for SageMaker training. That is, we're not starting the actual SageMaker training job using SageMaker training instances, but we're running it locally so that we can quickly reiterate, fixing bugs, looking for errors before we push the real training job. Our Docker image has been built, so we're good to go. So we can start the run the SageMaker job with this run SageMaker job script, providing the SageMaker config. So when we start it, it will first upload the SageMaker config to S3. It will upload the training config to S3, and the main purpose, as I've put in the repos README, is for the visibility across the team, so that every team member knows what parameters I've used to start this experiment, what parameters I have used for the networks, for the optimizers, and so on and so forth, so that these experiments are easily replicable. That's the main reason. And also another reason is we have quite a number of parameters for our networks. So we're trying to build a generative adversarial network. We have a generator, we have a discriminator. So we have these parameters, and I do not want to provide these parameters as arguments to the entry script on SageMaker Docker container, but I want to provide this as a config file which can be used by that entry script. So I am creating this config file and then pushing to S3, and that config file will be pulled back to the Docker container and then will be used. So now our SageMaker job has been started, but as you can see in the standard output, it has stopped somewhere. So this is the point where we have set our breakpoint, and it is paused there, and actually you don't have any interactive debugger right here. It is because this thing is just a standard output, and in order to have access to interactive debugger, you have to attach to this running Docker container, which we can do by first figuring out the idea of this running Docker container. After we got it, we can attach to it, and there you go. This is the PDB UI. It's pretty sleek, and you can see this little asterisk on the left gutter, and that is the breakpoint that I've set. And you can see the code. You can see the currently executing line. You can see the variables. You can inspect the variables, and also you can step in the code like this, and the variables will change depending on the newly created variables. So this is pretty useful. This debugger is. So if you can also use PDB, but PDB is not feature rich like that, and the user experience is not that great. So here you have pretty much all what you need for debugging very efficiently, rather than just printing things out or like trying to figure out whether certain things are properly assigned. One of the most important thing is we're trying to read data which is downloaded from S3 to the file system on Docker container. So you might have made a mistake in the file path, and then you might end up not actually reading the data, and then the program might quit because of an error. So another interesting thing useful thing that we can do is we can actually look into the file system of this Docker container to make sure that the resources that we have downloaded, actually we don't download, SageMaker have downloaded to this Docker container is where they're supposed to be. So like before, we figure out what the running Docker container ID is, and then we try to get the bash session into it. So it's 2F4E bin bash. So essentially now we're in the Docker containers file system here, Docker containers bash, and so these are the scripts that we have copied here, and then we have it all here. What we're more interested in is this folder called input and data. So when you go into input data, you'll see two folders, and that is because these are the two folders that I have specified as input channel when I started my SageMaker estimator. So if you go to run SageMaker job, and if you go to input channels, essentially before I start estimator.fit, so I provide input channels, and the input channels are these key value pairs of like train data and config, and the train data has the value of an S3 URI where the training data is, and the config has an S3 URI of my training config YAML file. So these keys are actually the folders that you actually find here, the config and train data. And if you go into config, you'll find this trainconfig.yaml, which essentially is the training config that I pushed to S3 and then pulled back. And if you go to train data, you'll find train folder with all the train images. Here I just put like only 100 images just for the sake of demonstration, but of course, depending on your data size, it'll take some more time to pull all this data to your Docker container first. So it is very useful to have a good understanding of where the resources are on that on that Docker container before you actually debug or test your code. Otherwise, you'll have no idea where things are, and it's not very good. So, okay, let's go back to our debugger. So in our debugger, we can keep on stepping, and then now I want to step inside this train loop. So let's just go to a point where we are loading, we're getting a batch from our data loader. Okay, so the command line part down below is actually like IPython interactive console, where you can just type in the variables or the Python statements here, and then it'll just be interpreted here. So let's say that the data 0 are images, and data 1 is our labels. So yeah, so we can keep on executing it. Data 0, we can get data 0 dot shape. Essentially, it'll give us, it's just like a batch size of 100. 3 channel images, each image is having the size 64 by 64. So essentially, it is very useful now that you know, like, okay, you can look at the each variables, what each variable is holding right now. So DGZ1 is actually so we pass this latent vector into the generator, and then into the discriminator, and after it has been, the weights have been updated, we see this value. So essentially, we now have a good overview of like how the trainer is going, what things are, pretty much what you can get if you use a normal GUI debugger. So yeah, that's pretty much it. That's how you can efficiently debug the code in the Docker container before you actually push it to SageMaker. Another thing that you can potentially do is you can actually use matplotlib to plot these tensors, convert them to, of course, detach them, put them on the CPU, convert them into NumPy array, and then you can visualize these using matplotlib, and then you can save the figures into the Docker file system, and then copy that file from Docker file system to your local machine, and you can take a look at the files and then see, oh, are my images actually properly loaded? Are they what they are supposed to be? So on and so forth. So you can debug in that manner. If you're satisfied with your debugging, you can just press C, and it will continue the execution until the end of the program, or until next breakpoint is encountered. So yeah, I only trained for a very short amount of time. So I've only put up very small amount of data, so the training completes very fast, and you see that the job is completed, and the container has been basically terminated. So now you have nothing left here. So yeah, I hope this helps you to be able to debug your code before you've actually started your SageMaker training job on SageMaker training instances.